In this video, we're going to talk about superposition of waves or wave interference. Probably the most distinct property between waves and particles is what happens when they try to occupy the same point in space. If we have two billiard ball-like particles that are coming towards each other, when they collide, one will bounce off in one direction, one will bounce off the other direction. And later we'll learn about the law of conservation of momentum that applies if these two objects collide with one another. This is completely different from what happens with waves. Since waves are a disturbance in a medium, when they try to occupy the same point in space, what happens is that there is a resultant wave. The resultant wave is the sum of the disturbances of the two individual waves. So if you have some wave coming in with like a pulse like that, and some other wave pulse coming in like this, and these guys are coming towards each other, then when they try to occupy the same point in space, let's say that this wave is 2 meters high, and this wave is 3 meters high, then the resultant wave is the sum of those two disturbances, and as a result would be 5 meters high, 2 plus 3. Keeping in mind that waves can disturb mediums in either direction, then let's say that this was 2 meters high and this is 1 meter down, then when we add those two waves, we take the one that is down as a negative to show that the resultant wave would only then be 1 meter high. So it's the sum of the two individual waves, but it's important to recognize whether you're dealing with a crest or a trough, whether you're dealing with a disturbance in the medium that is up or down, and take that into account when adding those two waves. As a result of that, we have two basic possibilities: constructive interference and destructive interference. Constructive interference happens when the resultant wave is larger than the original waves, and that's because the two original waves disturb the medium in the same way. So for example, we have a positive pulse meeting a positive pulse, forming a large positive pulse, or a negative pulse running into another negative pulse, forming a large negative or trough pulse. So those are our two options for constructive interference, and we notice that the resultant wave is larger than the original waves, or the resulting disturbance is larger. Alternatively, destructive interference occurs when the disturbance in the medium are in opposite directions. This results in a wave that is smaller than the original waves. For example, if a positive pulse meets a trough or a negative pulse, then the resultant wave would be smaller than the two waves that made it up in the first place. Particles collide. They cannot occupy the same point in space. They bounce off each other. Waves combine. When they do, we can get bigger waves or we can get smaller waves, depending on whether or not the original disturbances are working together or working against each other.